Okay, so Ratoma, ne? We're continuing the conversation here, probability, ne? Probability. And we are carrying on. The last time we discussed mutually exclusive events, I guess. Probably spelled last time wrong, but anyway, we were on mutually exclusive events, ne? O sa gopola mutually exclusive events e ko ra gore do you remember what mutually exclusive events means? And if you cannot maybe explain it mathematically, do you think you can show an example of what mutually exclusive event means? Or you can share an example?
I think mutually exclusive maybe probability is equal to 0.
When the probabilities are what?
I think mutually exclusive. Mutually exclusive. I think mutually exclusive again.
Okay.
I think really equal to.
Remember, it's when the probability of event A and B happening together is 0, ne? Another case is when P of A or B, so the probability of A or B happening is equal to the probability of event A1 plus another event. So again, the best example to explain mutually exclusive events, if you have two dice, let me just draw it now. So let's say nalama dice amabili. Akere wa dlala ludo. Salwa dlala ludo. Yes. So ludo re dlala ka ma dice, re chama dice. Ne? So there are 6 sides to a cube that makes up a die, ne? One die. So if we get a dice ra le putula, so geometry of 2D shapes. 1, 2, 3, 4. So geometry of 2D shapes, I get. So in geometry of 2D shapes, Jambo is it? Let me see. Why is it doing this? In geometry of 2D shapes, a cube will have 6 faces like this. And now a die, le dice, let's want a cube. Alright? So if we got putulul, if you open up a die, ne? If you open up a die, you'll see 6 faces like this. But now once you close it up, it becomes like this. So if le side le 1 le na le the number 2 on a die, and the other side has got the number 4 or the number 5 or the number 6. Chaya ludo, does it happen that kale dice le 1, ne? You will have 5 and 6 or 1 and 2 or 3 and 4 or even 5 and 4 or 3 and 1. Does it happen gore for 1, and does it ever happen mole dicing gore o be le 1 and 6 ka le dice le le teng di tlhagelle? Does it ever happen? Can it happen? It cannot, ne? So because it cannot, then we say the probability of 1 in 6 happening is 0. So in other words, the number of favorable outcomes for 1 and 6 to happen is not there. So because it's impossible, we say then this in terms of probability. And this also means that these events are mutually exclusive. So mutually exclusive mutually exclusive. Like if o tlhagella 1 e kgethollola tše dingwe, the other 5 numbers. If o tlhagella 6 e kgethollola tše dingwe, but only one must show up out of 6. So di ka se tšwe di le 2 or tee. That's what mutually exclusive means. In a situation yes, so le dice o ka se tšwe di number tše 2 le dice le le tee ka nako e 1. That's just what mutually exclusive means. So if o ka nagana ka mokgwa, and then you explain it in your own words if you're asked to describe it. Just think about le dice, on a die, you cannot have 2 and 5 appear at the same time. So those events are mutually exclusive. That's the long and short of what it means. Ne? Yeah, go on. Hey, Magdalene. All right. Awesome. So that's where we ended up last time. So now we're going to continue with complementary events. Ne? Okay. Complementary events. All right. So the word complement means something that completes an event or adds to what's missing to make up a whole. Ne? So let's say you are playing puzzle. Ne? You are playing a jigsaw puzzle, right? It's a jigsaw puzzle and it's got a painting of, it can be an object or a number of objects. Ne? But somewhere there is a missing puzzle, and that puzzle maybe so. Ne? So in the puzzle, a short arm. So we'll have the red, the blue triangle, we'll have a green, maybe square, and maybe we'll have a yellow circle. And the background is red. So that's our thing. Eh? Our background is red. And that's our puzzle. So the missing piece of the puzzle, kiyemo. So when we find the missing piece of the puzzle, maybe we put it in there, in the space where it belongs, then that puzzle will be complete. So the missing piece will complement. Ne? Will complement the puzzle. So far, yakwagala what the word complement means, ne? Do you understand the concept? Yeah, Magdalene? Hello? Okay. Pencil is a bit low on battery. But yeah, that's what the word complement means, ne? So complementary is an adjective and it means an event that completes or adds to other events to make the whole sample space. ne? And also, okay. Also, complement is to make whole or complete, and is not compliment e leng go kgotsa motho, ne? To praise or say something kind to someone, ne? So I can read, hey, well done, Magdalene, you kept time today. I'm complimenting you. I'm praising you for something that's correct, or I appreciate that you did, right? But when we speak about a compliment with E, not I, they sound the same, by the way. That's why it's easy to get confused with them. They sound the same, but they don't mean the same thing. So the word complement is to make whole or complete, whilst the word compliment is to praise or say positive words to someone else. Ne? So, back to probability. Events that are mutually exclusive and make up the whole sample space are called complementary events. So these are events that are mutually exclusive. So in other words, they can't happen at the same time. And they make up the whole sample. Ne? Make up the whole sample space. These are called complementary events. So there is no intersection and no elements from the sample set that are outside the two sets. So let's think about this again in terms of Rachayama dice, for example. Ne? So let's say we're rolling a die during Ludo. Ne? We're rolling a die during a game of Ludo. And yeah, whenever we have to roll a die, we have one of 6 options that could show up, right? So let's do 2, 4, 1, 2, 3, 4, 5. Yeah, I'll just draw that for now. Ne? So we're rolling a die, and we have a possibility of 1, 2, 3, 4, 5, and 6. Ne? Let me do this. Or 6. Okay, so the probability of rolling the number 4. Ne? How do we work it out? Do you remember the definition of probability? It's number. Do you remember it? Magdalene, do you remember the definition of probability? No, you don't. Okay, it's fine. If you don't remember, let's remind each other. It's the number of favorable events divided by number of possible events. And I'm taking us back there because this is the basis, yeah, probability, ne? Ne? So when we're rolling a die, the same definition applies, ne? Number of favorable events divided by number of possible events. So the probability of rolling the number 4, how would we calculate that? Using this definition. Favorable events ki chekai.
yeah, for 1/6.
Yes, it's over 1 over 6 because the number of favorable events ke 1 again. The number of events we want ke 1, which is the showing up of 4. But only possible which is 6. Ne? That's excellent. So this is the probability of rolling a 4. Ne? What about the probability of not rolling a 4? If we look at number
5.
5, yes. So number of favorable events over number of possible events. Yes, that's correct, ne? So number of favorable events would be 5 and number of possible events would be 6. So when we compare probability of rolling 4, the probability of not rolling a 4, then revale that, ne? So the event of not rolling a 4 is the complement of the event of rolling a 4. Ne? So think about it like this. The probability of rolling a 4 ke 1 over 6, and the probability of not rolling a 4 would be 5 over 6. Ne? So we symbolize it ka this thing yana there. It's not an exponent, it's just like a comma like there. Ne? So that means the complementary rule, ne, is the next conclusion we come to. Complementary rule, ne? It tells us that if we take the probability of an event, the probability of an event not occurring, then that must equal to 1. Ne? Because what happens if we take probability of A of 4 plus the probability of 4 not happening? This becomes 1 over 6 plus 5 over 6, which is 6 over 6, which equals 1. So that's where we get that's how we get the complementary rule. That means that the probability of an event not happening equals 1 minus the probability of an event happening. So in other words, the probability of not rolling a 4 is 1 minus the probability of rolling a 4. In other words, moki itoba probability of not rolling a 4 it will 1 minus the probability of rolling a 4, which is 1 minus 1 over 6, which is 5 over 6. So this rule, these two equations, they give us this complementary rule. Can you see that? Magdalene? All right. So let's quickly do an activity. So in an exam setting or test setting, maybe this one you can have 2 marks, ne? So we're going to do it, ne? So this one is from Mind the Gap, page 150. This pencil is really flat. We live in a strange time. Instead of saying my pencil is out of lead, I'm saying my pencil does not have battery. In a school, pencils would run out of lead, depending if like ink. But now in my class, I feel like a battery. I'm hoping it's a little bit charged now. Okay, so in our example, from Mind the Gap, grade 12 on page 150, we are given S, which is a sample, and S in our the following elements: 1, 2, 3, 4, 5, 6, 7. For A has got 1, 3, 5, and 7. And B gives us 2, 4, and 6. Ne? So what is the probability of choosing a number that is not in set A? Ne? What is the probability of choosing a number that is not in set A? Ne? So set A, sample space arena is so. Let's start with the sample space. Ne? We've got a rectangle there. Ne? Sample space, see? And then we've got the numbers 1 up to 7. And in event A, let's make it interesting. That's black, so this will be blue. I'll just make it an obvious contrast, so this will be red. Ne? Alright. So for event A, Renale 1, 3, 5, and 7. And for event B, okay. Maybe let's not go that far. It's not necessary because it's only 2 marks. It's only 2 marks. I just had an idea I want to try out. Okay. So remember I get referred to discuss the complementary rule. And it's that the probability of event A not happening is 1 minus the probability of event A happening. So let's start here. Ne? What is the probability that we will select an odd number from the sample set? So the probability of any number in event A is number of favorable outcomes divided by number of possible outcomes. And number of favorable outcomes for A give 4, but number of possible outcomes give 7. Ne? That means the probability of choosing a number that is not in set A is 1 minus 4 over 7, which is 7 over 7 minus 4 over 7. That gives us 3 over 7. And if you think about this, the probability of a number not falling in A is the probability of event B. Because the probability of a number falling in event B Illeganally, number of favorable outcomes would be 3, whereas number of possible outcomes would be 7. Does this make sense? Like it's like here we're saying the same thing, but we're just showing different sides of it relative to the other. Like more ke the same event relative to A, and more the same event but relative to set B. Wakush. Can you see that? All right. Okay. Then the next problem would be number 2 of the same activity on page 150 of Mind the Gap. And we have a sample space, and it features A, B, C, D, E, F, G, H, I, and J. And then in event A, Renale, A, E, and I, or RAE. Event B, Renale, B, C, D, F, G, and H, or H, depends on how you pronounce it really. And OC, we've got C, or rather B. We've got B, we've got H, and we've got J. Ne? So now we must draw a Venn diagram for S. So now we will do the box to show that this is the sample space. So there's S. Event A will put in blue. Event B will put in green. And event C will put in yellow. All right, so maybe we can put, black is fine for now. Okay, so Venn diagram S inale A, B, C, D, E, F, G, H, I, and J. So 10 alphabets. But event A inale A, E, and I. And it doesn't seem like those vowels overlap with any of the consonants. Ne? So the vowel, they don't overlap the consonants. So maybe we'll have A somewhere there, ya floater. And inale A, E, and I. Okay. Then event B, yonata binale B, H, C, D, F, G. So 1, 2, 3, 4, 5, 6, 3, 6. Okay, that's B. And then C, tshwantse overlap this one about those two. But it's only got 3 consonants, so J tabetsa maele tega mode. Do you follow how it works? So that's A, that's C, and that's B. Why, Wanama? Yeah, Magdalene?
Yes.
All right. So this one, when it's scored, how fuadi marks ne? I would like to think you will get a mark for the sample space and a mark for correctly identifying the Venn diagrams and I suppose the overlap. But the whole set get 4 marks. Ne? That's how it gets marked. Then the second question, but describe so but we must describe the set A. So set A is a set of vowels. Do you know what a vowel is? Eh? Do you know what a vowel is? Yes, and you know what a consonant is? All right, so yeah. So when we are asked to describe this set here, ne? When we are asked to describe this set here, set A, we simply have to describe a set of vowels from the letters A to J. Ne? That's all the answer requires. It's a set of vowels from A to J when you're counting down the alphabet. Or the set of first 3 vowels of the alphabet. So that's what we have to answer there. And you get 1 mark. 1 mark. Then we have to also answer the next question. Are there any complementary sets? Ne? Are there any complementary sets? Okay, are you asking a question? Yeah, ask.
Question number 1 is
Okay, question number 1, we have to draw the Venn diagram, which is this one. It's 4 marks. Then the second question from that one, we must describe set A. So it's a set of vowels from A to J or okay. So again, for this one, we have to describe whether or not the sets that are given, set A, B, and C, are they mutually exclusive or complementary? That's what we have to describe, ne? And what we have to do is we will have to I'm just really doodling on the screen with the laser pointer so that the screen doesn't switch off and then I stop recording. Whilst I wait for my pen to charge a little bit more. Okay, so complementary events simply means they are mutually exclusive and make up the whole sample space. Ne? So in the context here, this Venn diagram, sets A and B are they complementary or are they not complementary? What do you think? Set A and B.
I think the question A, are they mutually
Yeah, are they complementary or not complementary?
I don't think they are complementary.
Okay, so they are not complementary, ne? Okay. Complementary. Why do you think that is? Just give me your idea. I just wanna pick your brain.
I think because I think maybe because adding the way you want to know, maybe because adding sharing any alphabet addition.
Yeah. Well, A and B, they don't include the element J. You're correct there. Ne? So
Okay.
because they don't include J. Ne? And why is that important? B tells us about the consonants from B, C, D, F, G, and H. So it's all the consonants except J, right? So set B, all consonants, first consonants excluding J, ne? So it's first consonants except J, while set A is first vowels up to J, ne? First vowels up to J. So they are not complementary because they do not include J. Because if we are to work out P of B, for an example, it would be how many? 6 out of 10, whereas P of A would be 3 out of 10. Right? If we are looking with regard to our sample space. So 6 out of 10 plus 3 out of 10 does not equal 1. It gives us 9 out of 10. 1. So that's the first part. The second part that we also need to look at is between set B and set C. Ne? Can we say they are mutually exclusive? Set C and B, they are not mutually, are they mutually exclusive or are they complementary? What do you think? I'm not sure.
I think I don't think they are mutually exclusive because
Okay.
probability A D B very I can only 0, but instead is 0.9. So it's double the
Or for B and C?
B and A, sorry.
Or B and A? Yes, you are correct. Because when we add those two, they give us 0.9 and they don't give us 1. So they're not complementary. You are 100% correct there. So C is just 3 consonants really. And the probability of C would be 3 out of 10. Whereas the probability of B is 6 out of 10. And the probability of B plus the probability of C does not equal 1. Just like in the first case. So none of the sets are mutually exclusive, nor are they complementary. So for correctly identifying this part here and that part there, you'll get full marks, 2 marks, ne? So they're not complementary. Which sets are mutually exclusive but are not complementary? Yo, that's a interesting question. So, okay, mutual exclusivity does not equal complementary, ne? So this is an interesting one to answer. Mutually exclusive, how ropola gale dice 6 1. 6 cannot come up the same time as 1 on one die. So that means you have 2 possible events that don't happen at the same time. So B and A, what would you say about those two? Do they happen at the same time or have an overlap?
Which ones?
Event king set B and set A.
Set A and B.
Yeah, are they mutually exclusive or not?
They are. No. Set A and B, ne?
Yeah, are they mutually exclusive or are they not mutually exclusive?
No, they're not mutually exclusive.
Wait. Mutually exclusive means P A and B, right? Okay, but what about P A or what about the probability of A or B?
The probability of A or B?
Yeah.
Probability of being A.
Yes. No. So here's the correct way to think about it, ne? So in the first case, Moki, Mobere Araba number 3, ne? We were looking for complementary. I don't think I was very clear on that one. But we were looking for complementary sets. So we couldn't find any complementary sets. And the rule for complementary is that the probability of an event plus the probability of an event not happening must equal 1. So, the probability of event B, for an example, ne? Plus the probability of event B not happening which would mean event A does not equal 1. That's what this conclusion was. Yes, that's what this conclusion was. But I'll be very much open to correction from anyone really about this one. Then the second one was that also B and C are not complementary either, because when we add their probabilities, they also don't add up to 1. So this was about complementary. Okay, just to be clear. Complementary. So now this one asks about mutually exclusive. Ne? So mutually exclusive, we want to see which sets share elements in terms of mutual exclusivity. Because if they share elements, then they are mutually exclusive. One. So let's look at mutually exclusive only. Mutually exclusive means that the probability of an event A and B is 0. So event A event B. It's not possible. That's what we want to find out. So we can start off with the probability of A and B, as well as probability of B and C. All right. So for A and B, number of possible outcomes is 0 because arena more than A and B dikakan. So we don't have where A overlaps with B. Yeah, sure. Ask. This one, number King, this one.
Yeah.
Oh, okay. So they want to find out which sets are mutually exclusive but not complementary. That's what we want to answer here. Akush. All right. So we want to find these two probabilities, ne? And out of the 10, the probability of A and B happening is 0 out of 10. But the probability of B and C overlapping is 2 out of 10. So B and C are not mutually exclusive. But A and B are mutually exclusive, ne? And then at the same time, A and C, let's look at the probability of A and C. So we don't have an overlap between A and C, so it's going to be 0 over 10 as well. So A and C are also mutually exclusive, but they do not make up the whole sample space. So in other words, A and B as well as A and C are mutually exclusive, but they don't make up the whole sample space. So that's the long and short of it. And that also counts for 2 marks. 2 marks. 2 marks. 2 marks. Okay. So now we can move to. So far, Emapil, is that one clear, or should we repeat some more ideas from it?
Yeah, hopefully the repeating.
The repeat, eh? Okay. Okay, so in the third question, we're looking for sets that are complementary. So complementary means that the probability of the one plus the probability of the other must give us 1. Ne? So we set out to find the probability of the first consonants excluding J, as well as the probability of the first vowels up to J. So the probability of the first vowels, 3 out of 10. and the probability are the first consonants up to J, it feels 6 out of 10. To have events or sets to be complementary means that when you add their probabilities, you must get the number 1. But these two, they don't give us the number 1. So they are not complementary. Is that one clear? Okay, great. Then again, we also want to check if probability of B and C are complementary. Ne? So if the probability of B and the probability of set C add up to 1, then those two events, they are complementary. But now the probability of B is 6 out of 10 and the probability of C is 3 out of 10. When we add them, they refer 0.9 and that's not equal to 1. Therefore, they are not complementary. So it's the same thing, they are not complementary. All right, one. That one, is it sharp? Magdalene? Oh, okay. I lost you there. So that one, did you get it?
Yeah, okay.
Great, okay. So that one is about being complementary, ne? Because we were asked to explain if there are any complementary sets, ne? Now in the next part, we have to describe if there are any mutually exclusive sets, ne? So for mutual exclusive sets, then we must look at the probability of the two happening equaling 0. So we don't have a case where event A or set A overlap with set B. A di tlhagelele go tee or di share the elements. So the probability of A and B is 0, as well as the probability of A and C. Alright. So what does that tell us? It tells us the probability of A and B is 0. It tells us that A and B are mutually exclusive. A and C having a probability of 0 tells us that A and C are mutually exclusive. So in other words, we can have event A and event B, but they cannot happen at the same time. They don't have an overlap. Same as event A and C, they don't have an overlap. So that's what that means. If we look at the probability of B and C, we get these two here, which is 2 out of 10. And what that tells us is that these are not mutually exclusive. So you can have one with the other. So we just had to describe between A and B, we have mutual exclusivity, and between A and C, we also have mutual exclusivity. And then you get a 1 mark and 1 mark. Alright, one. All right. So I'm glad it's clearer. Okay. So the last thing we can look at is events which are not mutually exclusive, ne? which are not mutually exclusive. Okay, so sometimes two events have some outcomes that are the same. For an example, if we have a sample space looking something like this, and the one event is blue, the other event is red, and in our sample space, we've got event A, event B. We've got the numbers 6 and 12, 3 and 9. Oh, interesting. 1, 7, 5, 11. And outside here we have 2, 4, and 10. All right. So the sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Ne? So set A is between the numbers 1 and 12, 3, 6, 9, and 12. Whereas set B is odd numbers. 1, 3, 5, 7, 9, and 11. Ne? So oof, my handwriting, or am I tired? Yeah, I probably should sleep soon. Multiples of 3, and here it's odd numbers, ne? All right, so we've got odd numbers and multiples of 3. Ne? Let me just a couple of seconds charge this. So this set is odd numbers, and the blue set is multiples of 3. 3, 6, 9, 12. So up to 12 is just 4 numbers. All right. Then looking again at the same sample. Yeah, ask.
Number second, I go left again.
This one here. Okay, so it's A for this set. And then this one is B. The red set is B. Yes, my handwriting was off there. Ne? Sorry about that. Sorry about that. Okay. So the probability of event A would be 1, 2, 3, 4 out of 12, which is 1 over 3. And the probability of event B would be 2, 4, 6, 6 out of 12, which is a half. Ne? So if we take the probability of A, the probability of B, that would be a half plus a third, which is 6 over 12 plus 4 over 12, which is 10 over 12 or 5 over 6. Yeah? Okay. So remember, from our probability laws, this is the probability of A or B. Ne? And it is the chance of getting numbers in set A or set B. we cannot count the numbers 3 and 9 for both sets because we cannot repeat numbers in the intersection. So, what does this tell us? It tells us, this is gonna get really a lot. It's gonna get really a lot. It's gonna get really a lot. Yeah, but let's just hang in there. Ne? So let me first erase this. Ne? We've just calculated this. Let me erase this as well. It's gonna get really a lot. But yeah, the probability of getting numbers in A or numbers in B, ne? Is the chance of getting numbers in A or the chance of getting numbers in B. Right? So we cannot count 3 and 9 for both sets. So in other words, where A and B, or rather P of A and probability of B intersect, where A and B intersect, we cannot repeat those numbers, ne? We cannot repeat those numbers. So, the probability of A or B therefore becomes 8 out of 12. Ne? That's because but this tells us that P of A plus P of B does not equal probability of A or B. Ne? So remember in our initial description of mutually exclusive events, ne? The probability of A or B equals the probability of A plus the probability of B. But that is for mutually exclusive events. So in events that are not mutually exclusive, in this case, we don't have events, we have an overlap. So these two events are not mutually exclusive. Okay? And that is because we have an intersection between the two events. So in other words, for us to make these two equal, we need to subtract the intersection of the two events. Yeah, it said it's going to be a lot. So what this means is the probability of A or B will equal the probability of A plus the probability of B minus the intersection of A and B, right? So the intersection of A and B is gonna lead 2 out of 12, which simply relates us to these two numbers there, right? And why is that important? If we do not subtract the probability of the intersection, then we are assuming that the two events are mutually exclusive. But now they are not mutually exclusive, which is why we must subtract this intersection here. So intersection is subtracted because A and B are not mutually exclusive. And this becomes our another law that we can apply in probability. Another rule, rather, that we can apply in probability. Ne? So, okay, and it actually gets interesting going forward. But it's fine. Let's start here. Ne? So let's do a quick activity. Then we'll call it a night. So in this activity, also from Mind the Gap, MTG is on page 153. Ne? We have a group of learners, 50 of them. 35 take maths, 30 take history. I should probably write those in uppercase because they are names of, yeah. And then 12 learners do not take math or history. All right, so first things first, we must draw a Venn diagram to represent this information. And how do we do that? How do we do that? So we will do it like this. We'll do it like this. We can try doing it like this. How much time have we got on this call? Got 45 minutes. Okay. Yeah, ask. Oh, askis. Okay. So we just started the question. Yeah. So 35 learners take maths, 35 take history. Ne? So we need to draw a Venn diagram for this information. So number one, Venn diagram. We have a sample space. It's got 50 learners. And that sample space will have event M and event H. So M will represent maths and H will represent history. All right. Okay. So this one we really need to think, eh? We really need to think. We've got 35 learners taking maths out of 50 learners, and we've got 30 learners taking history out of 50 learners, but we've got 12 learners that do not take maths or history. So we're gonna list some unknowns somewhere there in the problem. And how do we do that? So 35 learners from maths, maybe not. So the number of learners that we have doing maths is a certain amount, and the number of learners that we have doing history is a certain amount. But somewhere between the two, we will have where there's an overlap between maths and history learners, but we also know that 12 learners are not taking maths and are not taking history. But we know that out of 50, we must have the 12 learners that are not taking maths or history, and the number of learners that we don't know where maths and history overlap. We don't know the number of them, but we know that there are 12 that are not taking maths or history, and we know that, or rather, let's do this. Yeah. We know that there are learners that are not taking maths or history, and we know that there is information about learners that are taking maths and history, but it's somewhere in this information. So if we draw a Venn diagram, yes, 35 will do maths, 30 will do history, but so that means we have 50 minus 35, which is 15, but we also have 50 minus 30, which gives us 20. So somewhere between 15 and 20, we have learners that are doing math and history combined. So because we're not sure what's going on there, we'll just put an X there. So that's why I wrote the X there. Ne? So since we know this much, we know that over here we've got 50 learners and 35 are here. So if we have 35 and we minus X, you know what? Can I have some time to go over this problem? Then we can discuss it in our next probability class. Ne? Because I don't want to. Yeah, let's do that. And I'm also feeling tired. So yeah, we'll call it a night, and then I'll see you on Monday. Tomorrow we're not having class now. Are you attending?
No.
Oh, okay. Tomorrow let's not have class, and I'm also behind on a couple of administrative issues. I need to send you an invoice as well. So let's not have class so I can finish off my admin, and then we'll have class on Monday. Ne? Okay. Check it out on Mind the Gap. Engage with the problem, and then we can talk about it on Monday. I would really like if you would say, no, I tried it. This is what I understand. What do you think? I would really, really love that conversation, Abon. So help me out with that, and then we'll take it from there. All right. Good night.